Hi again, everybody. This is Steve Harvey, and this will be graphing the cosecants and secants. Let's go ahead and begin. Oops, let's see. That's my homework for my students right there. Okay, so we're going to graph the cosecant, y equals cosecant right here. So what I'm going to do is, there's a sine curve, you guys. The cosecant is the reciprocal of that. So that's the sine curve, and I'm going to reciprocate that. Okay, now where this goes through 0, remember sine starts and ends at 0, halfway at 0, halfway at +1, halfway at -1, and you complete that curve right there. Okay, the cosecant is where these zeros are. The reciprocal of zeros, there's going to be asymptotes. So I'm going to have an asymptote there, an asymptote there, an asymptote there. Okay, so it's going to be there's the asymptotes, and then you just have horseshoes going off the tips of those. Okay, that's your cosecant curve right there. Okay, you just got to, it's just the horseshoes off the tips of your sine curve right there. Okay, let's graph the secant curve. Let me remind you what the cosine curve is. The cosine curve starts and ends at 1, halfway at -1, halfway at 0. Okay, so the secant is the reciprocal of cosine. So where the zeros are on cosines, there's going to be asymptotes there. Okay, and then horseshoes off in the middle, and then they just kind of flare up to the right. So I mean, if I continued, I'd have another asymptote over here, and it would flare up over there, and I'd have another asymptote going over here, and it would flare up over there. Okay, that's your secant graph right there. All right, easy, huh? Okay, cotangent. Let's do the cotangent again. We did this in the last lesson, you guys. So tangent starts and ends at 0, halfway at 0, and then halfway asymptotes, halfway +1, -1. So the cotangent is the reciprocal. So it's going to start and end. Instead of having zeros, it's going to start and end at asymptotes, halfway at asymptotes, and then it goes halfway at goes +1, -1, +1, -1. So there's the cotangent one from the last one. Okay, let's graph this guy. Okay, pretend like that's a sine curve, and then we'll reciprocate it and do the horseshoes. Okay, so first of all, it has a midline right there at +2 right there. Okay, and the phase shift is always opposite c, which is this guy over here, over k, which is the number in front of theta, which is 1/2. Okay, so that gets me my phase shift is going to be pi/2, and it's going to be to the right because of that minus sign. The midline's +2 because of that +2 right there, and your period is k in 2 pi. In this case, my k is 1/2, so it's 1/2 in 2 pi. And just think of that like an equation. 1/2 equals 2 pi. Multiply both sides by 2, you get 1 in 4 pi. So my period's going to be in 4 pi. All right, so here we go. So my midline's there, up there at 2. My phase shift is pi/2 to the right, so that's what this is, pi/2 to the right. And it's going to be 1 period happens in 4 pi. So here's my 4 pi right there. Okay, pi/2 plus 4 pi, because we're doing that. Okay, sine starts and ends at 0. I'm sorry, starts and ends at, at 0, halfway at 0, halfway at 1, halfway at -1. That's the sine curve. And then so the cosecant curve is going to have asymptotes where the zeros are right there, and then horseshoes at the other parts right there. All right, pretty groovy, huh? Okay, so let's graph this guy. 2 secant. Okay, my amplitude is 2 because of this 2 right there. My period is 1 because this says there's 2 periods in 2 pi, so 1 period's in 1. All right, here's my midlines down at -1 right there. My phase shift is opposite this guy over this guy right here, so it's going to be pi/4 to the left. Okay, so and there's 1 period in pi. All right, so let's go ahead and do that. So there's my my midline right there. Okay, and instead of starting and ending, cosine starts and ends at 1, but it's going to start and end at 2 from here. So I'm going to go up 2 and down 2, starting and ending, and it's in every pi, you guys. So I'm going to start it and end it at pi, and then phase shift it over to the left, pi/4. Okay, excuse me, I'm coughing. I'm getting a little choked up there. And then so start and end it at 2, halfway at -2, halfway at zeros right there. Okay, now the zeros on the midline right there, since it's secant, it's going to be the reciprocal of those, so there's going to be asymptotes right there, and then we're going to horseshoe off those asymptotes. Okay, there it is right there. All right, so write an equation for the given function given the period, phase shift, and vertical shift. Okay, so this is a secant function. Period is 1, so that means there's going to be a 2 in front of the theta. The phase shift is pi/3, and the vertical shift is -3. All right, so actually this should be a -3 right there. All right, so everything else is cool though. So The phase shift is opposite c over k, and I know that's 2 right there, so it's going to be opposite c over 2, cross multiply, and you get your phase shift to be 2 pi over 3. And this should, the only mix-up I have is that should be a minus 3 right there, because your vertical shift is down there at minus 3. So let me change that to minus 3. Okay, everything else is cool. All right. Okay, what else do I have here? Okay, tangent function. Period is 2 pi. So remember, tangent function, one period's in pi, so there must be a 1/2 in front of the angle theta right there. So k is 1/2. My phase shift is opposite c over k. So it's opposite c over 1/2, and I know it's pi over 2, so I get c to be negative pi over 16 right there. Okay, and the vertical shift is plus 2, so there's my equation right there.